There's a profound and, I think, quite beautiful idea that our intuition is a kind of comfortable lie the universe tells us, a simplification just to help us get by, to allow us to navigate our immediate world, to find food, to avoid predators, to build societies. But to truly grasp the nature of reality, from the bizarre behavior of the quantum world to the incomprehensible scale of the cosmos, we have to perform an act of intellectual bravery. We have to be willing to let go of what feels right, to abandon our common sense, and instead place our trust in the cold, uncompromising and deeply elegant language of mathematics. It's through that lens that we can begin to perceive the truths that so wonderfully defy our everyday experience. Sometimes, though, our brains are a little too eager to find meaning, to find patterns where none exist. Our imagination, hardwired over millions of years of evolution, can sometimes perceive things on other worlds that simply aren't there. A classic and I think rather wonderful example is the infamous face on Mars. It all began back in 1976, a truly pioneering time in space exploration. The NASA orbiter, Viking 1, was circling the red planet, sending back the very first detailed impressions of its surface. And from a region called Cydonia, it transmitted a particular frame, a photograph of a geological structure, a hill, a mesa, really, which under a very specific angle of sunlight, and with the relatively low resolution of the Viking camera, bore an absolutely uncanny resemblance to a human face. It was all there, what appeared to be eyes, a nose, a mouth, all staring out into the void. This single photograph, as you can imagine, caused an immediate global sensation. It was everywhere. It circulated around the world, sparking a torrent of the most wonderfully wild speculation. Was this an ancient Martian civilization? Were these artificial structures a kind of Martian sphinx gazing with silent stoicism across the red plains? And of course, once you start looking for one pattern, your brain starts finding others. Nearby, in the same images, other structures were found that appeared to resemble pyramids and even the layout of a city. The face on Mars very quickly became an iconic symbol of the red planet's enduring mystery and a powerful emblem of that profound, deep-seated human hope that one day we might find traces of intelligence out there among the stars. Alas, as is so often the case in science, the more prosaic, though no less interesting truth emerged. No miracle occurred. Much later, vastly superior images of Cydonia were captured, first by the Mars Global Surveyor in the late 1990s, and then by subsequent orbiters equipped with cameras of far, far higher resolution and under very different lighting conditions. And these new, clearer impressions definitively showed that the face is merely a natural geological formation, a heavily eroded mesa sculpted by wind and time. There are no artificial features whatsoever. It's a classic textbook example of a phenomenon called pareidolia, a fascinating psychological quirk where our brain, which is so exquisitely hardwired to recognize familiar patterns, especially faces, tends to perceive them in random or ambiguous stimuli. It's why we perceive animals in the shapes of clouds, or faces in the patterns of wallpaper, or, in this compelling case, the natural contours of Martian hills. Our brains are, in essence, face detection machines, an evolutionary inheritance that was incredibly useful for telling friend from foe on the African savannah, but can be easily fooled by a trick of light and shadow on another world. So there is no Martian sphinx. But the story of the face on Mars itself remains an amusing, and I think deeply illustrative, episode in the history of space exploration. It demonstrates so clearly how easily our powerful, pattern-seeking imaginations can, at times, deceive us, projecting our own hopes and our own forms onto the grand, indifferent canvas of the cosmos. The face on Mars was indeed an illusion, a beautiful trick of light and shadow playing on our innate psychology. But if we venture further out, to the distant frozen outskirts of our solar system, we find a unique pair of worlds, Pluto and Charon, a duo that is very real and highly unusual. Pluto, as we now know, is classified as a dwarf planet, a demotion that caused no small amount of public debate, but which reflects a deeper understanding of the solar system's architecture. And Charon is its largest moon, a substantial companion discovered way back in 1978. So why then are they often referred to as a double dwarf planet system? Well, it all boils down to their relative sizes and masses, and the beautiful, elegant dance of gravity that binds them together. You see, Charon is simply enormous compared to Pluto. Its diameter, approximately 1,212 kilometers, is more than half of Pluto's diameter, which measures about 2,377 kilometers. To put that in perspective, that represents the largest moon-to-host size ratio in the entire solar system. Our own moon is large, but it's only about a quarter of the Earth's diameter. Furthermore, Charon's mass is about 1/8 of Pluto's mass, a truly significant fraction. And because of this remarkable distribution of mass, their common centre of gravity, the precise point around which both celestial bodies orbit, known as the barycenter, is located not inside Pluto itself, but rather in the empty space between them. Think about it. Most moons, by contrast, orbit a point that lies deep within the interior of their parent planet. For example, our own moon and Earth revolve around a barycenter that is still beneath the Earth's surface. But Pluto and Charon perform this majestic, graceful waltz around a point in the emptiness that separates them. This is the defining characteristic of a true double-planet system. It's not just a moon orbiting a planet, it's two worlds orbiting each other. And there's more. They are mutually tidally locked. This is a fascinating consequence of long-term gravitational interaction. It means that Pluto perpetually shows the exact same face to Charon, and conversely, Charon perpetually shows the exact same face to Pluto. If you were hypothetically to stand on the Charonian side of Pluto, Charon would hang motionless in your sky, a vast pale disk that never rises or sets, only ever changing its phases as the distant sun illuminates it from different angles. Such complete mutual tidal locking is also remarkably unique for large celestial bodies in our solar system. Although the International Astronomical Union doesn't officially employ the term double dwarf planet, informally it perfectly describes this extraordinary gravitational relationship, and the data from the New Horizons mission, which conducted that historic flyby of Pluto and Charon in 2015, revealed that both are surprisingly complex and geologically diverse worlds, far more active and dynamic than we ever imagined. Pluto with its vast nitrogen ice glaciers and towering mountains of water ice, Charon with its deep canyons and strange reddish polar cap. They are not just a gravitational curiosity, they are two fascinating worlds, locked in a perpetual silent dance on the edge of darkness. So what other strange partnerships and unseen influences might be shaping our cosmic neighbourhood, perhaps in ways we haven't even begun to suspect? Pluto and Charon are a very real, very unique pair, but what if our own sun had a companion? A dark, unseen partner responsible for periodic catastrophe here on Earth. This is the basis of the Nemesis hypothesis, a purely hypothetical companion star to our Sun, a dramatic and compelling concept proposed back in the 1980s to explain a supposed, and I must stress, statistically debated periodicity in mass extinctions. The idea, put forward by a group of scientists including the physicist Richard Muller and the paleontologist Walter Alvarez, who had earlier famously linked the extinction of the dinosaurs to a catastrophic asteroid impact, was compellingly simple. Our Sun, they suggested, might possess a dim, unseen evil twin, a star they named Nemesis. It would most likely be a red dwarf, the most common type of star in the galaxy, or perhaps a brown dwarf, a failed star, not quite massive enough to ignite nuclear fusion. This Nemesis star would be orbiting our Sun in an extraordinarily elongated, highly eccentric path with a period of approximately 26 to 30 million years. Once during this colossal orbit, while passing closest to the Sun at its perihelion, Nemesis was theorized to intrude into the Oort cloud. Now, the Oort cloud itself is a hypothetical vast spherical shell of trillions of cometary nuclei, a sort of cosmic freezer full of icy remnants from the formation of the solar system, believed to encircle us at immense distances, perhaps a light year away. Nemesis's immense gravity, it was theorized, would perturb the delicate orbits of these comets, sending a veritable cometary shower hurtling into the inner solar system. This would, in turn, sharply increase the probability of a large comet colliding with Earth, thereby causing periodic mass extinctions such as the cataclysmic event that wiped out the dinosaurs 66 million years ago. That event could have been triggered by such a nemesis impact. It sounds incredibly intriguing, doesn't it? A compelling narrative for cosmic catastrophe, a hidden agent of doom in our own backyard. But there are significant problems with the idea. Firstly, the very periodicity of mass extinctions, which was derived from a painstaking analysis of the fossil record, occurring every 26 to 30 million years, is statistically very debatable. Many scientists believe it might simply be a coincidence, a statistical artifact in what is inherently noisy geological data, rather than a genuine underlying astrophysical cycle. It's very difficult to pull a clean signal out of the messy, incomplete record of a life on Earth. Secondly, and this is the crucial point, there is absolutely no observational evidence for Nemesis's existence. Astronomers have diligently searched for a dim companion to the Sun for decades, utilizing various powerful telescopes, including infrared sky surveys like WISE, the Wide Field Infrared Survey Explorer, which are exceptionally adept at spotting cool, dim stars and brown dwarfs, and nothing suitable has ever been found. Thirdly, from a celestial mechanics perspective, maintaining a stable orbit with such an incredibly vast period over billions of years is mathematically very difficult. Such an orbit would be highly susceptible to gravitational perturbations from passing stars and the immense tidal forces of the Milky Way galaxy itself. So today, the Nemesis hypothesis is considered extremely unlikely by most of the scientific community. It's primarily of historical interest, a fascinating what-if in the annals of science, a testament to our search for patterns and explanations for the great dramas of Earth's history. Nemesis is a hypothetical companion, an attempt to explain our history by an influence from the outside. But the Big Bounce theory is a profound hypothesis that fundamentally changes our perspective on the very beginning and, potentially, the end of the universe itself. It offers a truly intriguing alternative to the standard Big Bang model, specifically attempting to resolve the fundamental problem of the initial singularity and daring to answer that ultimate and perhaps unanswerable question: what came before? The central idea is that our universe did not begin with an infinitely dense, infinitely hot point, a singularity. Instead, it cycles endlessly through alternating periods of expansion and contraction. What we commonly refer to as the Big Bang was, in this model, actually the Big Bounce, the pivotal moment when a previous contracting universe reached a state of maximum density, but crucially not infinite, and minimum size, but crucially not zero, and then bounced, beginning to expand anew, giving rise to our current cycle of the universe. This model elegantly avoids the problematic singularity, a point where our known laws of physics, specifically Einstein's general theory of relativity, completely break down. A singularity is, in essence, a sign that your theory is incomplete. The precise mechanism of the bounce itself is usually attributed to the profound effects of quantum gravity, the yet-to-be-discovered theory that unifies gravity with quantum mechanics. These quantum effects are predicted to become dominant at the extreme densities and energies near the bounce, and could provide a kind of repulsive force, a quantum pressure that prevents a complete, absolute collapse into nothingness. The Big Bounce theory often emerges within the intricate framework of loop quantum gravity, one of the leading candidate theories for quantum gravity. This theory predicts a discrete quantum structure of space-time itself. It suggests that space isn't a smooth, continuous fabric, but is made of fundamental, indivisible loops or atoms of space-time. At the smallest possible scale, you can't get any smaller, and this fundamental graininess might naturally lead to such a bounce, preventing the universe from crushing itself out of existence. This model envisions a universe without a true beginning or end, eternally pulsating, perhaps even with the fundamental physical laws subtly changing in each successive cycle. But much like string theory, this remains for now a purely theoretical construct. We currently possess no direct observational evidence that definitively confirms or refutes the Big Bounce, although scientists are actively searching for possible subtle traces of it, perhaps hidden in the cosmic microwave background radiation the faint afterglow of the Big Bang, or bounce. It's a beautiful idea, replacing a singular violent birth with an endless rhythmic cosmic breath. From such grand global theories about the birth of everything, let's return to a specific and, I find, rather amusing event in the rich history of space exploration, the curious incident of playing golf on the moon. Yes, that actually happened. It occurred during the Apollo 14 mission on the 6th of February 1971. The astronaut Alan Shepard, who, incidentally, held the distinction of being the first American in space way back in 1961, decided to pull off a little surprise, an unscheduled demonstration for the folks back home. Towards the very end of his second moonwalk, he ingeniously produced an improvised golf club, the head of a 6-iron, which he'd clandestinely attached to the handle of a sample collection tool, and 2 golf balls he had secretly brought all the way from Earth. Now, due to the bulkiness and restrictive nature of his spacesuit, he had to swing the club with only one hand, a rather awkward maneuver. The first shot was, reportedly, not great. He sort of duffed it and the ball didn't travel very far. But the second shot was notably better. Shepard then joyfully reported back to Mission Control in Houston that the ball went for miles and miles and miles. Of course, this was a characteristic astronaut's exaggeration, a moment of pure, unadulterated joy. But, due to the moon's incredibly weak gravity, which is a mere 1/6 of Earth's gravity, and the complete absence of air resistance in the lunar vacuum, the ball did indeed travel significantly farther than it ever could on Earth. Later estimates, based on analysis of the mission footage, suggest a remarkable distance of about 200 to 400 yards. Not bad at all for a one-handed swing in a bulky spacesuit. Officially, this charming stunt was not part of the mission's meticulously planned scientific program, which was primarily focused on collecting geological samples and setting up experimental equipment in the Oumuamua formation. It was more of Shepard's personal initiative, a playful demonstration of the peculiar effects of lunar gravity, and simply a fun, memorable gesture that has since become one of the most iconic and beloved moments of the entire Apollo program. It was a human moment, a moment of playfulness amidst the vast, sterile grandeur of the lunar landscape. One of the golf club heads, by the way, is now proudly housed in the Museum of the United States Golf Association. It reminds us that exploration isn't just about data and science, it's also about the human spirit. Astronauts played golf, but our robotic rovers, our tireless explorers on Mars, sometimes find rocks that evoke entirely different, often whimsical, associations in people. For example, there was the so-called Martian spoon. Back in 2015, NASA's ubiquitous Curiosity rover photographed a small, elongated rock on the rugged surface of Mars with a distinct depression at one end, bearing a striking, almost uncanny resemblance to a spoon or a ladle. The photograph, as you can guess, quickly went viral online, sparking another wave of excited theories about ancient Martian civilizations and lost, tantalizing artifacts. But NASA scientists, as they so often have to, swiftly dispelled the intrigue. The spoon is merely a natural geological formation, the exquisite result of countless millennia of wind erosion. Over millions and millions of years, the Martian wind, carrying fine abrasive particles of sand and dust, acts like a relentless sandblaster, carving bizarre and intricate shapes out of the planet's rocks. This particular rock likely consisted of materials of varying hardness, and the wind simply blew away the softer parts more quickly, leaving behind the harder, more resistant handle and scoop. This is once again a prime example of pareidolia, our inherent tendency to perceive familiar shapes in random objects. And Martian rovers have found numerous other strange rocks over the years, some resembling small pyramids, others that have been nicknamed donuts, or those perfectly round blueberry spheres, which turned out to be hematite concretions discovered by the Opportunity rover, evidence of ancient water. The spoon is just another fascinating exhibit in this Martian cabinet of natural wind-sculpted curiosities. It's a reminder that nature, given enough time, can be a sculptor of immense and surprising creativity. The spoon mystery is solved, a simple case of our brains playing tricks on us again. But the story of the penis drawing on the moon and the Moon Museum is not pareidolia. it is a quite man-made curiosity, a piece of clandestine art history related to the Apollo 12 mission, the second lunar landing, in November of 1969. The audacious idea for the Moon Museum originated with an artist named Forrest Myers. He became passionately driven by the concept of sending miniature artworks by famous contemporary artists to the moon. He successfully managed to gather works from 6 renowned masters of the era: Andy Warhol, Robert Rauschenberg, David Novros, John Chamberlain, Klaus Oldenburg, and Myers himself. All these tiny drawings were exquisitely engraved onto a small ceramic tile, no larger than a pinky fingernail, measuring approximately 2 by 1.3 centimeters. Myers, however, was unable to secure official NASA permission to send this clandestine museum. It wasn't exactly part of the mission plan, but, according to his widely recounted story, through some engineer acquaintances, he managed to arrange for the tile to be secretly affixed to one of the landing legs of the lunar module Intrepid just before its launch. Among the 6 drawings was Andy Warhol's contribution. It is a stylized sketch that many people unequivocally interpret as a drawing of a penis, although alternative interpretations suggest it could be his initials, A and W, cleverly combined, or perhaps a stylist rocket. The ambiguity is classic Warhol. If Myers' account is to be believed, and while there is no official NASA confirmation, the story is widely known and accepted in the art world. This tiny ceramic tile, bearing its 6 mini masterpieces, including Warhol's provocative contribution, remains on the moon, left behind with the landing stage of the Intrepid in the vast ocean of storms. It can be considered the very first, and certainly very informal, art object ever delivered to another celestial body. The existence of this drawing and the museum only became widely known decades later, and it inevitably caused mixed reactions. For some, it was a daring, rebellious prank, a piece of anti-establishment art smuggled to the heavens. For others, an intriguing act of underground art, a secret message to the cosmos. It's a strange and wonderful footnote in the story of our first steps away from home. Does it matter if our art is sometimes mischievous? Art on the moon, faces on Mars. This is all fundamentally about our perception, isn't it? And yet humanity once perceived the universe itself in a radically different way, placing ourselves unequivocally at its centre. The profound idea that the Earth, and often, more specifically, a particular civilization upon it, was the undisputed centre of the cosmos was deeply prevalent in most ancient cultures. This geocentric model was most fully developed and articulated by the ancient Greek astronomer Claudius Ptolemy in the 2nd century of the Common Era. In his intricate and mathematically sophisticated system, the Earth rested motionless at the central core, while the Moon, the Sun, all the known planets, and the encompassing sphere of fixed stars revolved majestically around it, on a complex system of circles and epicycles. This model, based on the apparent motion of celestial bodies as experienced from Earth, seemed logically consistent and, for the most part, it worked. It dominated European thought for over 1,400 years. The intellectual revolution arrived with Nicholas Copernicus in the 16th century. He boldly proposed the heliocentric model, in which the Sun, not the Earth, was the true centre, and Earth was merely one of several planets orbiting it. Initially, Copernicus's groundbreaking ideas met with fierce resistance and skepticism, not least from the established church. It was a demotion, a profound shift in our place in the universe. However, Galileo's revolutionary telescopic observations, such as the phases of Venus, which showed it orbited the Sun, and the discovery of moons orbiting Jupiter, proving that not everything orbited the Earth, and Johannes Kepler's precise mathematically derived laws of planetary orbits irrevocably confirmed the correctness of heliocentrism, and Isaac Newton provided the definitive physical explanation for this model with his universal law of gravitation, cementing its scientific validity. But the story doesn't end there. In the 20th century, with Edwin Hubble's astonishing discovery of the expanding universe, the realization that distant galaxies are actively moving away from us and from each other, it became profoundly clear that the universe has no single, preferred center in the traditional sense. Expansion, it turns out, happens equally everywhere. If you imagine the universe as an expanding raisin cake, each raisin, representing a galaxy, moves away from all the other raisins, but no single raisin is the unique centre of the cake. On the larger scales, the universe appears remarkably homogeneous and isotropic, meaning it feels and appears roughly the same at all points and in all directions. This fundamental concept is called the cosmological principle. And this implies that the universe has no preferred centre or edge. Any point can legitimately consider itself the centre of its own observable expansion. This profound understanding finally stripped Earth and humanity of any truly privileged position in the vast indifferent cosmos. We went from the centre of everything to a tiny speck in a limitless, centreless expanse. A humbling, but I think ultimately liberating realization. The universe has no single centre, but within our own solar system, there are specific places that are now the intense focus of scientists tirelessly searching for extraterrestrial life. And one of the most promising, most tantalizing of those places is Europa, a fascinating moon of Jupiter. Beneath its remarkably thick, icy crust, estimated to be from 10 to 30 kilometers deep, a vast body of evidence suggests there lies a global ocean of liquid saltwater. There might be, according to cautious estimates, 2 to 3 times more water there than in all of Earth's vast oceans combined. So, how does this immense body of water remain liquid so far from the warming rays of the sun, out in the frigid outer solar system? The answer lies in a process called tidal heating. The immense gravitational pull of the giant planet Jupiter, along with the regular gravitational influences of the neighbouring large moons like Io and Ganymede, constantly squeezes and stretches Europa, flexing its interior like a squash ball. This ceaseless deformation generates internal friction and, crucially, enough heat to maintain its massive subsurface ocean in a liquid state. Now, this subsurface ocean likely comes into direct contact with the moon's rocky seafloor, and this particular detail opens up a truly stunning possibility. Here on Earth, a unique and vibrant ecosystem thrives around hydrothermal vents, often called black smokers, which exist on the ocean floor. These are places where superheated water, richly laden with minerals from the Earth's interior, erupts from fissures in the crust. Life flourishes around these vents: bacteria, archaea, strange tube worms, mollusks. Entire, vibrant ecosystems existing without a single photon of sunlight, deriving their energy not from photosynthesis, but from chemical reactions through a process known as chemosynthesis. It is highly probable that similar hydrothermal vents exist on Europa's ocean floor as well, and if so, then all the conditions we deem necessary for the origin and sustained existence of life might be present there. Liquid water, an abundant energy source, chemical in nature, and all the necessary chemical elements like carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur, which could have been delivered by impacting asteroids or leached from the moon's rocky core. Europa's enigmatic surface displays numerous cracks and intricate fractures, often stained a peculiar reddish-brown hue, possibly by salts or complex organic matter brought up from the ocean and subsequently altered by Jupiter's intense radiation. Even possible geysers, actively erupting plumes of water from the ocean into space, are occasionally observed. All these compelling factors combine to make Europa a prime, unparalleled candidate for the search for life beyond Earth. The upcoming NASA mission, Europa Clipper, with its launch meticulously planned for 2024, is specifically designed for a detailed, unprecedented study of Europa, its ice shell, its hidden ocean, and the fervent search for definitive signs of habitability. Could the first life we ever discover be thriving in a dark, crushing ocean, billions of kilometers away, utterly oblivious to the light of any star? The search for life on Europa is grounded in rigorous scientific data and meticulously planned future experiments. But some philosophical arguments concern the very nature of belief and the elusive concept of evidence itself. A classic example of this is Russell's teapot. This witty, thought-provoking analogy was ingeniously proposed by the brilliant British philosopher and mathematician Bertrand Russell around 1952. Imagine, Russell posited, that I claim that between Earth and Mars a porcelain teapot orbits the Sun in an elliptical path. but it is so incredibly small that even our most powerful telescopes cannot possibly detect it. Can you, he asked, definitively prove me wrong? No, of course you can't. But does that, Russell argued, mean that you should believe me? Absolutely not. The crucial burden of proof, he emphasized, always lies with the person making the positive claim, especially if that claim is about the existence of something and is, by its very nature, unfalsifiable, meaning it cannot be tested or disproven. One cannot logically demand that others disprove one's unsubstantiated assertions. Skepticism towards such claims is, therefore, the only logical and rational position. Russell's analogy is frequently employed in profound discussions about religion, which was his original context, but also about pseudoscience and the myriad of conspiracy theories that circulate in our modern world. It powerfully underscores the paramount importance of evidence and falsifiability, the very possibility of being proven wrong, for any claims aspiring to be scientific or rational. The absence of evidence of absence, we cannot prove the teapot isn't there, is not fundamentally evidence of presence. We have no legitimate grounds to believe it is there. It's a vital tool for critical thinking in a world full of extraordinary claims. Russell's teapot elegantly illustrates the burden of proof for things we can't detect. But sending human ashes into space is a well-documented, albeit largely symbolic fact. The first person whose remains were intentionally delivered to another celestial body was the famous planetary geologist Eugene Shoemaker. He was a true giant in his field, co-discovering the comet Shoemaker-Levy 9, which spectacularly collided with Jupiter. He harboured a lifelong dream of visiting the moon himself, but tragically he failed the medical examination required for astronaut selection. After his death in a car accident, NASA decided to fulfill his fervent dream posthumously, a beautiful and fitting tribute. A small capsule containing a portion of his cremated remains was placed aboard the Lunar Prospector probe, which was launched in 1998. In July of 1999, upon the completion of its mission to map the moon's surface, the spacecraft was deliberately crashed onto the moon's surface near its south pole, and thus Eugene Shoemaker found his final resting place on the moon, the world he had studied with such passion. As for ashes sent beyond the solar system, the first individual to achieve this was Clyde Tombaugh, the dedicated astronomer who famously discovered Pluto back in 1930. A small portion of his ashes is reverently carried aboard the New Horizons probe, the very same spacecraft that gave us those stunning close-up impressions of Pluto and Charon. It was launched in 2006, flew past Pluto in 2015, and is now continuing its epic journey out into interstellar space, carrying a tiny piece of its discoverer with it. The private company Celestis also offers services to send symbolic portions of ashes into space, including those of Star Trek creator Gene Roddenberry and his wife Majel Barrett, the actor James Doohan who played Scotty, and others. These remains have been sent on various rockets, into Earth orbit, to the Moon, and future interstellar missions are planned. These are, for the most part, deeply symbolic acts, a poignant way for loved ones to honour the memory of the departed by associating them with the boundless dream of space exploration, a final journey into the great unknown. Ashes in space are minuscule particles of matter, but space itself, the vast expanse between the stars and galaxies, is primarily a vacuum. That is, it is space virtually devoid of any substantial amount of substance. The density of matter in interstellar space is incredibly, astonishingly low, just a few hydrogen atoms per cubic meter. For comparison, the air at Earth's surface contains an astounding 10 to the power of 25 molecules per cubic meter. And intergalactic space, the vast voids between the galaxies, is even emptier still. But it is critically important to understand that this vacuum is not absolute emptiness. Firstly, there are still those rare scattered atoms, ions, molecules, and microscopic dust particles. Secondly, space is thoroughly permeated by electromagnetic radiation, starlight, the cosmic microwave background radiation, the echo of the Big Bang, and by neutrinos, those elusive, almost massless particles that stream through everything. Thirdly, gravitational and magnetic fields exist throughout the cosmos. weaving an invisible web across the void. And then there is the strangest aspect of all, the quantum vacuum. According to the profound insights of quantum field theory, even seemingly empty space is, in reality, buzzing with an astonishing amount of activity. Pairs of virtual particles and antiparticles are constantly and spontaneously being born into existence and immediately vanishing back into nothingness in a timescale so short we can never directly detect them. These are the so-called zero-point fluctuations of the vacuum, or vacuum energy. And these quantum fluctuations are not merely a mathematical trick. They have observable, verifiable effects, such as the Casimir effect, the subtle attraction between two closely spaced uncharged metal plates in a vacuum, which is caused by the fact that fewer virtual particles can pop into existence between the plates than outside them. There's even a tantalizing hypothesis that this vacuum energy might be intimately related to the dark energy that is causing the universe to expand with acceleration, although there is a colossal problem with the staggering discrepancy between the theoretical calculations and the observed actual value of this energy. On Earth, creating a high vacuum is immensely important for a multitude of advanced technologies and scientific research, and for a human being, existing in the vacuum of space without the protection of a spacesuit is fatally dangerous, primarily due to the instantaneous lack of external pressure, which would cause body fluids to boil, and of course, the absence of oxygen. The vacuum is not empty. It's a seething cauldron of potential. Quantum fluctuations of the vacuum are already quite strange in themselves. But some theories push even further, suggesting that the Big Bang itself could have been the result of a quantum phenomenon, namely quantum tunneling. What precisely is quantum tunneling? It is a purely quantum mechanical effect where a particle can leak or tunnel through an energy barrier, even if it does not possess enough energy to simply jump over it, according to the deterministic laws of classical physics. Imagine a ball rolling towards a hill. Classically, it will not overcome it if it lacks sufficient speed. But in the quantum world, there exists a non-zero probability that it will simply appear on the other side of the hill, having tunneled through, defying classical intuition. How can this astonishing concept be applied to the birth of the universe? Well, there are several fascinating hypotheses. One, proposed by the brilliant cosmologist Alexander Vilenkin, suggests that the universe could have literally tunneled into existence from a state of nothing, where nothing is understood in a very specific physical sense, perhaps as the absence of classical spacetime itself, a quantum state of pure potential. Another idea posits that our universe arose as a result of tunneling from some previous metastable state, a sort of false vacuum within string theory, like a bubble forming in a pot of boiling water. Yet another well-known and profound concept is the no-boundary proposal, put forth by Stephen Hawking and James Hartley. Utilizing the intricate mathematical apparatus of quantum cosmology, including the abstract concept of imaginary time, they described a model of the universe that possesses no initial singularity and no edge in time. The universe, in this view, smoothly emerges from quantum fluctuations without a clear, discrete starting point. It just is. This elegantly bypasses the vexing question, what was before the Big Bang, because in this model, there is no before. All these ideas are, of course, highly speculative and rely on a currently unverified theory of quantum gravity, but they powerfully demonstrate how physicists are striving to apply the most fundamental laws of nature to grapple with the biggest mystery of all, the ultimate origin of everything. Quantum effects might indeed be behind the very birth of the universe. But Einstein's general theory of relativity, which so eloquently describes the force of gravity as the curvature of space-time, also mathematically allows for the theoretical existence of objects that are the complete inverse opposite of black holes, white holes. If a black hole is a region from which absolutely nothing, not even light, can escape due to the presence of its event horizon, then a white hole is a hypothetical region into which nothing can enter from the outside. Instead, matter and energy can only erupt, burst forth from it. White holes emerge as valid mathematical solutions to Einstein's equations, particularly in the so-called maximally extended Schwarzschild spacetime, which describes an idealized, eternal, non-rotating black hole. they fundamentally represent the past of the event horizon, whereas the black hole represents its future. The mathematics even tantalizingly hints at a possible connection between black and white holes through a wormhole, an Einstein-Rosen bridge. Matter, theoretically, falls into a black hole, passes through this cosmic shortcut, and is then ejected from a white hole somewhere else in space, or sometime else in time, or even in an entirely different universe. It sounds like a thrilling, ready-made plot for the most imaginative science fiction, doesn't it? But, alas, there are many critical buts that lead most physicists to consider white holes to be physically unrealistic. Firstly, it is profoundly unclear how they could possibly form in nature. We understand that black holes form from the catastrophic gravitational collapse of massive stars, but no such physical mechanism is known or even conceived for white holes. They would seemingly have to exist primordially, having been present from the universe's very beginning. Secondly, they are predicted to be extremely unstable. Any minimal amount of matter attempting to fall onto a white hole from the outside would, according to the calculations, probably instantly cause it to collapse into a black hole. Thirdly, white holes spontaneously ejecting matter and energy would fundamentally violate the second law of thermodynamics, as they would be decreasing entropy, or disorder, which is strictly forbidden for closed systems. And of course, we possess absolutely no observational evidence for the existence of white holes anywhere in the cosmos. So, most likely they are merely an interesting mathematical artifact of the elegant theory of gravity, a ghost in the machine, rather than real, tangible cosmic objects. White holes as exits to other universes are still very much in the realm of science fiction, but the very idea of multiple universes has some fascinating theoretical basis, especially within the profound concepts of eternal inflation and the existence of pocket or bubble universes. As we recall, inflation is that period of super rapid, exponential expansion that is thought to have occurred in the very first fleeting moments after the Big Bang. The theory of eternal inflation suggests that this process, once initiated, may never completely cease on the grand scale of the entire meta-universe. While in some specific regions, like our own observable universe, inflation stops due to localized quantum fluctuations, thereby giving birth to a bubble or pocket universe, with a normal slower rate of expansion. In the vast space between these bubbles, inflation can continue indefinitely, endlessly, generating ever more new bubble universes like foam on a cosmic ocean. In this mind-boggling picture, our observable universe is merely one of a potentially infinite number of such bubbles, all existing within a gigantic, eternally inflating multiverse. And what is most profoundly interesting is that each such pocket universe could, in principle, possess its own unique set of physical laws, its own fundamental constants, and even a different number of spatial dimensions. They could be unimaginably different from our own. These universes are generally considered to be causally disconnected from each other. The space between them expands faster than the speed of light, making any travel or information exchange between them fundamentally impossible. Why is such a complex, seemingly fantastical picture needed? Well, firstly, it is a rather natural, even inevitable, consequence of many of the leading models of inflation. Secondly, it offers a possible, albeit controversial, solution to the profound fine-tuning problem. Why do the fundamental constants in our universe, the precise strength of gravity, the exact mass of the electron and so on, have precisely the values that miraculously allow for the existence of stars, planets, and ultimately life? If there is a vast, possibly infinite number of universes, each with a different set of constants, sometimes referred to as the string theory landscape, then it is not surprising that we, as observers, find ourselves living in precisely the universe where the conditions for our own existence happen to be suitable. This line of reasoning is called the anthropic principle. Of course, the idea of pocket universes and the multiverse is highly speculative. We have no, and perhaps never will have, direct observational evidence of their existence. It remains the domain of theoretical physics and cosmology, based on extrapolating known laws to extreme, unimaginable conditions, a grand and beautiful, if unproven, vision of reality. From the incomprehensible scale of the multiverse, Let's return once again to Jupiter's moon Europa and its captivating, mysterious colours. We already mentioned that its icy surface is riddled with an intricate network of cracks and chaotic terrains, many of which exhibit a peculiar pinkish, reddish, or brownish hue. These colours are particularly noticeable along prominent linear features, known as lineae, and in areas where the ice crust has clearly been disrupted and churned up. So, where does this enigmatic pinkish grey or reddish-brown ice truly come from? Understanding its origin is critically important, as it could hold the key to discerning the chemical composition of Europa's hidden subsurface ocean. The main hypothesis currently links these distinctive colours to hydrated salts that are believed to rise from the ocean to the surface through cracks or hypothetical geysers. These could be compounds such as magnesium sulfate, which we know as Epsom salt, sodium chloride, ordinary table salt, and other complex compounds formed by the intricate interaction of the ocean water with the moon's rocky seafloor. Once these salts reach the surface, they are subjected to the intense, relentless radiation from charged particles trapped in Jupiter's powerful magnetosphere. This radiation induces profound chemical changes in the salts, a process known as radiolysis, which damages their crystal structures and creates defects that absorb light in specific ways, imparting the characteristic reddish-brown shades to the ice. Laboratory experiments, in which various salts were meticulously irradiated under conditions meticulously simulating Europa's harsh surface environment, do indeed demonstrate the formation of similar colours. Other possible components that might contribute to the colour include sulfur compounds, possibly transported from the neighbouring volcanically active Munio, or even complex organic molecules known as tholins, which are formed by the irradiation of simpler organic substances like methane or ethane. The exact composition of this coloured material, however, remains unknown. Spectrometers aboard the future Europa Clipper mission will be crucial in analysing the light reflected from these areas to precisely determine their chemical makeup and, potentially, shed invaluable light on the profound chemistry of the ocean hidden beneath that colourful fractured ice. Unravelling the precise chemistry of the coloured ice on Europa is a formidable task reserved for future missions. But unravelling the precise location and ultimate origin of the famous WOW signal has proven to be an insurmountable task so far. We recall that unique 72-second radio signal from 1977, strong, narrow band, arriving precisely at the frequency of neutral hydrogen, a sort of cosmic calling card. But where exactly did it originate? The Big Ear radio telescope at Ohio State University that detected it had a clever design with two feed horns that meticulously scanned the sky as the Earth rotated. If the source were a constant and truly distant object in space, it should have first passed through the field of view of one feed horn, and then, a few minutes later, through the field of view of the second. However, the WOW signal was detected by only one feed horn. It was conspicuously absent in the second one. This fact profoundly complicates matters. Either the signal source abruptly turned off, or moved away during the brief few minutes between the feed horn's passes, or it was not a stationary distant object at all. Because of this crucial detail, and the relatively wide beam of the telescope, we only know the general direction in the sky from which the signal came, an expansive area in the constellation Sagittarius, near the Chi Sagittarii star group. But there are many stars within this region, and determining which one, if any, emitted the signal is fundamentally impossible without a definitive redetection. There was a recent hypothesis that the signal could have been caused by hydrogen clouds surrounding comets that happened to be in that area of the sky in 1977, but this was subsequently refuted, as comets simply do not emit radio waves in that specific narrow-band manner. So the mystery endures. We still do not know what it was, nor precisely where it came from. A single, powerful shout in the cosmic darkness, and then silence. And then, in October of 2017, another visitor arrived, of a completely different kind, but no less shrouded in mystery. Oumuamua. This was the first ever conclusively recorded interstellar object, meaning it was a cosmic vagabond that journeyed to us not from our own solar system but from the unfathomable depths of space, from the realm of another distant star. The name Oumuamua itself is Hawaiian, a poetic and fitting choice, meaning something akin to scout or messenger arriving first from afar. Its trajectory through our system was definitively hyperbolic, and its speed was enormous, approximately 87 kilometers per second as it rounded the sun. These irrefutable facts left no room for doubt. It was not a local resident. It was simply a transit passenger, briefly passing through our planetary neighborhood. But what precisely was so profoundly strange about Oumuamua that it ignited such fervent discussion among scientists and the public alike? Well, firstly, there was its extraordinary shape. We couldn't perceive it in intricate detail. It was far too distant and far too small. But based on how much and how regularly its brightness fluctuated as it tumbled and rotated, astronomers meticulously concluded that Oumuamua possessed a remarkably elongated shape. Imagine a colossal cigar, or perhaps an extraordinarily flat pancake. Its length-to-width ratio was estimated to be at least 5 to 1, and possibly even as extreme as 10 to 1. Its dimensions were roughly several hundred meters long and only several dozen meters wide. Such an extreme shape is exceptionally atypical for the asteroids and comets in our own solar system, which usually resemble more amorphous potatoes, or simply shapeless lumps. This anomaly alone was enough to cause considerable head-scratching within the scientific community. Secondly, and quite puzzlingly, Oumuamua displayed absolutely no cometary activity whatsoever. It flew quite close to our Sun, even closer than the orbit of Mercury. Typically, when icy comets approach our star so intimately, their constituent ices begin to vaporize under the intense heat and solar wind, forming a distinct gas and dust cloud known as a coma, and often a trailing tail. But nothing of the sort was observed with Oumuamua. No coma, no tail. This crucial absence indicated that it was most likely a rocky or metallic object, akin to an asteroid, rather than an icy body like a comet. And here is where it becomes most profoundly interesting, the third and most perplexing strangeness. Meticulously analysing its trajectory after its passage past the Sun, astronomers discovered that Oumuamua exhibited a small but distinct non-gravitational acceleration. It was moving away from the Sun slightly faster than it should have if only the gravity of the Sun and planets were acting upon it. For comets, such a phenomenon is commonplace and easily explained. Their acceleration is attributed to the reactive thrust generated by the very evaporating gases that create the coma and tail. Gases are expelled in one direction. The comet receives a propulsive push in the opposite direction. But Oumuamua had no visible gases. How then could its inexplicable acceleration be explained? Several hypotheses were proposed. Perhaps it did release gas, but of a type we simply couldn't detect. For example, pure hydrogen, which is notoriously difficult to perceive. Or perhaps it was an immense iceberg composed of solid nitrogen, similar to the surface of Pluto, and its subtle evaporation was imperceptible to our instruments. Another idea suggested solar radiation pressure. Light, although massless, carries momentum and can exert a minute but continuous pressure on objects. But for this pressure to cause a noticeable acceleration in an object the size of Oumuamua, it would have to be incredibly lightweight and possess an enormous surface area, to put it simply, be extremely thin, like a vast solar sail. And this is where the renowned Harvard astronomer Avi Loeb stepped in, proposing the boldest and most provocative hypothesis of all. What if Oumuamua is not natural, but an artificial object? A piece of alien technology, perhaps that very solar sail, or some other advanced probe now derelict or broken? This audacious hypothesis, as you might imagine, provoked a storm of emotion and considerable criticism within the scientific community. Most scientists still lean strongly towards more natural, albeit unusual explanations, such as the nitrogen iceberg or a peculiar fluffy dust cloud. The profound problem is that Oumuamua was discovered when it was already rapidly moving away from us, and there was catastrophically little time for detailed, in-depth study. We can never hope to catch up to it and examine it up close. It has returned to the boundless interstellar depths, leaving us with far more questions than answers. But it showed us one crucial thing. Interstellar space is not empty. Objects truly fly through it, and they can be profoundly different from what we are accustomed to in our own solar system. Astronomers are now waiting with doubled enthusiasm for new scouts from afar, fervently hoping that next time we will be far better prepared. Oumuamua came from afar and has now left, but right next to us, in our own solar system, there exists a world that is perhaps most strikingly similar to early Earth, only in a deeply frozen version. This is Titan, Saturn's largest moon. Titan is utterly unique. It is the only celestial body in the entire solar system, apart from Earth, known to possess stable bodies of liquid on its surface, but it is not water. Due to the extreme, unimaginable cold, the surface temperature on Titan hovers at approximately minus 179 degrees Celsius. Water there is as hard and brittle as rock, but methane and ethane, which are gases on Earth, behave like liquids on Titan. Titan's atmosphere is remarkably dense, even denser than Earth's, and consists primarily of nitrogen, much like our own planet, but with a significant admixture of methane, about 1.5 to 2%, and a smaller amount of ethane. And something truly amazing unfolds on Titan, a complete methane cycle, a perfect analogue of our planet's water cycle. Methane evaporates from the surface, rises to form clouds in the dense orange hazy atmosphere, and then methane and ethane rains fall from these clouds, carving out entire rivers, forming vast lakes and even immense seas of liquid hydrocarbons. The Cassini spacecraft, which devoted many years to studying the Saturn system, and its Huygens probe, which even achieved a historic landing on Titan in 2005, was able to meticulously sense through the dense, hazy atmosphere, revealing these astonishing landscapes using its radar. Most of Titan's lakes and seas are concentrated in the frigid polar regions, particularly in the northern hemisphere. The largest of these is Kraken Mare, yes, named after the mythical sea monster, and for good reason. Its colossal area is estimated at over 400,000 square kilometers, which is larger than the area of the Caspian Sea on Earth. There are other large seas as well, Ligeia Mare and Punga Mare. These hydrocarbon bodies possess sharply defined shores, strikingly similar to Earth's fjords, and are apparently quite deep. Cassini's radar was even able to measure the depth of some lakes, reaching tens or even hundreds of meters. Can you truly imagine a world where methane rains fall from the sky, methane rivers flow across the land, and entire seas of liquid natural gas slosh about under an alien sun? It is utterly incredible, and that's not all. Beneath this exotic surface and its thick, icy crust, scientists suspect Titan may conceal yet another ocean, a global ocean of liquid water, possibly mixed with ammonia, which would act as a powerful antifreeze. So Titan is a world graced with liquid both on its surface and hidden beneath it, a world with complex organic chemistry unfolding in its atmosphere. Under the influence of sunlight, methane breaks down and forms complex hydrocarbons that settle on the surface like a kind of organic soot, creating vast dunes of organic sand. All these extraordinary factors combine to make Titan one of the most interesting and promising places to search for conditions suitable for the origin of life, albeit perhaps not life as we know it, but an entirely alien biochemistry, thriving in liquid methane instead of water. Speaking of names, Kraken Mare is one thing, but the planet Uranus had an amusing and rather convoluted naming story. In 1781, the English, though German by origin, astronomer William Herschel, diligently perceiving the sky with his powerful homemade reflecting telescope, noticed a dim, previously uncatalogued object that clearly moved against the background of fixed stars. At first he thought it was simply a comet, but meticulous calculations of its orbit soon revealed the astonishing truth. It was a new planet, the first to be discovered since ancient times. This was a tremendous, groundbreaking discovery, pushing the known boundaries of the solar system far beyond Saturn. As a gesture of profound respect for his patron, the reigning British monarch King George III, Herschel proposed naming the new planet Georgium Sidus, which is Latin for George's star. However, this name, although used for some time in Britain, never truly caught on within the broader international astronomical community. Most astronomers believed they should adhere to the established tradition and name newly discovered planets after gods from Greco-Roman mythology. The German astronomer Johann Bode, therefore, proposed the name Uranus, after the ancient Greek god of the sky, who was fittingly the father of Saturn, Cronus, and the grandfather of Jupiter, Zeus. This logical progression of familial relationships, Saturn's father, seemed convincing, and the name Uranus was eventually adopted universally. So, George's star remained merely a charming curiosity in the history of astronomy. Names are one thing, but when something strikingly resembling terrestrial structures is perceived on other planets, a completely different, often sensational story begins. Remember the face on Mars? Well, around the same era, in the early 1970s, another pioneering NASA spacecraft, Mariner 9, which was the first artificial satellite to orbit Mars, transmitted impressions from a different region, Elysium Planitia. And these impressions revealed structures strikingly similar to pyramids. Several prominent hills, each approximately 500 meters high, exhibiting quite regular geometric faces, numbering from 3 to 5. Of course, this immediately generated huge interest and sparked a new wave of excited speculation about an ancient Martian civilization that supposedly built pyramids, much like the Egyptians on Earth. Interest was particularly fueled by the fact that the Elysium region is renowned for its geological activity, hosting several large volcanoes. Perhaps the Martians strategically built their monumental structures near these powerful energy sources. Alas, just like with the face, further, more detailed studies utilizing more modern spacecraft and vastly superior imaging capabilities ultimately showed that the pyramids of Elysium are also, unequivocally, the result of natural geological processes. Most likely they are volcanic cones, long extinct and heavily eroded, or so-called yardangs, distinctive rock formations meticulously sculpted by millions of years of relentless wind erosion. The wind on Mars, although operating in a very thin atmosphere, is perfectly capable of carrying abrasive dust and sand, gradually shaping rocks and giving them bizarre, sometimes geometrically regular forms. So, although these Martian pyramids feel profoundly intriguing in old, low-resolution impressions, they are natural formations, not man-made monuments. But the intense interest in them, along with the face, undoubtedly played a significant role in popularizing the captivating idea of possible past life on Mars. From the illusory pyramids of Mars, let's now move to a completely real and truly grand phenomenon, the Great Red Spot on Jupiter. This is perhaps the most famous and unequivocally the longest-lasting storm in the entire solar system. It is majestically located in Jupiter's southern hemisphere, at approximately 22 degrees south latitude. By its very nature, the Great Red Spot is a colossal anticyclone, that is, a high-pressure region rotating counterclockwise in the southern hemisphere. Its sheer dimensions are simply staggering. It is larger than our entire planet Earth. Winds within this colossal vortex scream at speeds exceeding 500 kilometers per hour. The first definitive observations that can be confidently linked to the Great Red Spot date back to the 17th century. It might have been initially perceived by either Giovanni Cassini or Robert Hooke. Since then, the spot has been perceived almost continuously, making it the longest-lived atmospheric vortex known to humanity. It has raged for at least 350 years. However, over the past several centuries, astronomers have noted an alarming and persistent trend. The Great Red Spot is gradually inexorably shrinking. In the late 19th century, its length was estimated at a colossal 40,000 kilometers. By December of 2023, according to meticulous NASA data, it had diminished to approximately 13,332 kilometers. That is, in a mere century and a half, it has shriveled by almost 2/3. It is also progressively becoming more circular in shape. Why this is happening, and whether the spot will eventually disappear completely, remains unclear. Perhaps it is simply part of some vast, long-period atmospheric cycle, or perhaps the storm is indeed gradually dissipating its immense energy. Recent studies utilizing the Juno spacecraft, which is currently orbiting Jupiter and peering beneath its turbulent clouds with microwaves, have shown that the roots of the Great Red Spot extend incredibly deep into the planet's atmosphere, down to an astonishing depth of up to 500 kilometers. This is far, far deeper than previously thought, and considerably deeper than typical storms on Earth. This indicates that the Great Red Spot is not merely a surface phenomenon, but a powerful, deeply rooted, and extraordinarily resilient structure. Yet the precise reason for its characteristic red, or rather orange-brown colour is still debated. One leading hypothesis links the colour to complex chemical compounds rising from Jupiter's depths, possibly containing sulfur or phosphorus, which are then transformed into intricate coloured molecules, or chromophores, by the sun's powerful ultraviolet radiation in the upper cloud layers. But the exact composition of these cosmic dyes has not yet been definitively determined. The Great Red Spot stands as a true natural laboratory for studying the complex atmospheric dynamics of giant planets. Jupiter has the Great Red Spot, a titan of a storm that endures for centuries. But its younger brother, the distant ice giant Neptune, also had its own famous spot, albeit with a completely different, much more ephemeral fate. In 1989, the intrepid Voyager 2 spacecraft, during its historic flyby past Neptune, experienced a gigantic dark storm in its southern hemisphere, which was aptly named the Great Dark Spot. It too was an immense anticyclone, measuring approximately 13,000 by 6,600 kilometers, roughly comparable in size to Earth. The winds within it were even more furious, more extreme than on Jupiter. Voyager 2 recorded speeds up to an astonishing 2,100 kilometers per hour, an absolute record for the solar system. It seemed as though Neptune had acquired its own long-lived formidable superstorm. But imagine the profound surprise of scientists when, just 5 years later, in 1994, the Hubble Space Telescope turned its powerful gaze towards Neptune, and the Great Dark Spot was simply gone. It had utterly vanished. This stunning observation demonstrated that Neptune's atmosphere, although appearing calmer and less turbulent at first glance, is actually extraordinarily dynamic, and its giant storms are far less stable, much shorter-lived, than Jupiter's enduring Great Red Spot. They can appear and disappear within just a few years or mere decades. Since then, Hubble has indeed observed the appearance and subsequent disappearance of several other dark spots on Neptune, appearing in both its southern and northern hemispheres. In 2018, Hubble was even able to capture the actual birth of a new dark spot in the northern hemisphere, the very first time its formation could be meticulously tracked. A smaller spot for a brief time appeared nearby, affectionately nicknamed Dark Spot Junior. Recent research suggests that these dark spots on Neptune might not represent the storms themselves, but rather act as windows into deeper, darker atmospheric layers. Perhaps they are regions where the upper layer of bright methane ice clouds thins or dissipates, allowing us to perceive the darker layers of gas beneath. Why they form and disappear so quickly is still not fully understood, but it makes Neptune an even more mysterious and scientifically compelling planet, a world of fleeting, violent beauty. The colossal storms on Jupiter and Neptune are undeniably impressive, but for us Earthlings, other objects in space cause much greater and more immediate concern, the potentially hazardous asteroids, or PHAs. These are asteroids or comets whose orbits approach Earth's orbit very closely. By definition, less than 0.05 astronomical units, which translates to about 7.5 million kilometers, or approximately 20 times the average distance from Earth to the Moon. And critically, their size is large enough to cause significant, potentially catastrophic destruction in the event of a collision with our planet. The generally accepted size threshold for PHAs is usually set at 140 meters in diameter. An object of this size impacting Earth could devastate an entire city or trigger a massively destructive tsunami. To date, astronomers have discovered over 2,300 such potentially hazardous asteroids, and their number is constantly growing as our telescopes and meticulous monitoring programs become ever more sophisticated. It is vitally important to understand, potentially hazardous does not imply that such an object will definitively collide with Earth. It only signifies that its orbit comes sufficiently close that there is a theoretical possibility of a collision in the distant future, and therefore it requires careful, continuous tracking. One of the most famous examples of a PHA is the asteroid Apophis. It was discovered in 2004, and the initial calculations of its orbit caused quite a stir, even a momentary panic, in the scientific community and the media. These early calculations showed a non-zero, albeit small but statistically significant probability of Apophis colliding with Earth in 2029, and then again, even more ominously, in 2036. Apophis is a fairly large object, approximately 370 meters in diameter, so a collision would indeed have been catastrophic. This alarming news was widely discussed, fueling numerous apocalyptic scenarios. Fortunately, further, much more precise observations utilizing advanced radar and powerful telescopes allowed for a significant refinement of Apophis's orbit. And now, the probability of collision in both 2029 and 2036 has been completely ruled out. In April of 2029, Apophis will, however, fly incredibly close to Earth, just 31,000 kilometers above the surface, even closer than the orbit of our geostationary satellites. It will be a unique spectacle, potentially perceivable to the naked eye. This close approach will offer an unprecedented opportunity for scientists to study it up close, but it poses absolutely no threat of impact. To prevent future, potentially devastating catastrophes, special programs for monitoring near-Earth objects are actively in place. One such is the Center for Near-Earth Object Studies, or CNEOS at NASA, which continuously tracks known asteroids, refines their orbits, and meticulously assesses collision risks hundreds of years into the future using its sophisticated Sentry system. Furthermore, strategies for deflecting asteroids from dangerous trajectories are being actively developed and even rigorously tested. One promising approach is the kinetic impactor, ramming an asteroid with a spacecraft to slightly alter its velocity and, consequently, its orbital path. This groundbreaking technology was successfully tested by NASA's DART, the Double Asteroid Redirection Test, mission in 2022, which intentionally impacted the moonlet of the asteroid Dimorphos and successfully changed its orbital period. Another method is the gravity tractor, strategically placing a massive spacecraft near the asteroid and using their mutual, subtle gravitational attraction to very slowly but surely tug the asteroid onto a safe orbit. There are also more exotic, speculative ideas, such as using powerful lasers or even nuclear explosions as a last desperate resort. So while the cosmic threat undeniably exists, humanity is actively working to detect it, understand it, and ultimately prevent it. From real threats, let's return to linguistic curiosities. We already talked about George's star and its eventual displacement, but the name Uranus in English is associated with a persistent problem, or rather, an endless source of schoolyard jokes. Its pronunciation is, unfortunately, very similar to the phrase, your anus. This, of course, leads to countless puns, especially in English-speaking popular culture. The poor planet has become the object of constant giggles and snickering. Although, to be precise, the original name of the ancient Greek god of the sky, Uranus or Ouranos, is pronounced more like Uranos or Uranos, which is not nearly as ambiguous. Some astronomers and linguists even advocate for using this more authentic pronunciation to avoid awkwardness and maintain historical connection, but it seems the linguistic ship has sailed, and Uranus is now firmly embedded in the English language, with all the ensuing comical consequences. Jokes about this name are truly everywhere. For example, the animated series Futurama features a recurring gag that in the year 2620, astronomers, utterly exasperated by the incessant puns, officially renamed Uranus to Eurectum to put an end to that stupid joke once and for all. Such, alas, is the sometimes unfortunate reality of planetary linguistics. Uranus was renamed jokingly, but there was a planet that was searched for in all seriousness, with intense dedication, but was ultimately never found: Vulcan. In the mid-19th century, the brilliant French astronomer Urbain Le Verrier, justly famous for mathematically predicting the existence and precise position of Neptune based on perplexing anomalies in Uranus's orbital motion, turned his keen attention to similar, albeit more subtle, problems with the orbit of Mercury. Mercury's orbit also behaved not quite as perfectly predicted by Newtonian mechanics. Its closest point to the Sun, its perihelion, precessed or shifted slightly faster than it should have. By logical analogy with his triumph with Neptune, Le Verrier hypothesized that these minute deviations were caused by the gravitational influence of an unknown planet, located even closer to the Sun, nestled between Mercury and our star. He christened this hypothetical planet Vulcan, after the Roman god of fire and the forge. In 1859, a French amateur astronomer named Edmond Lescarbot excitedly reported to Le Verrier that he had perceived a dark object transiting the Sun's disk, a transit that could have been Vulcan itself. Le Verrier was thrilled and triumphantly announced the discovery. In the following decades, other reports of similar observations trickled in from various astronomers, seemingly confirming its existence. Active searches for Vulcan began, especially during solar eclipses when the elusive planet might be perceivable near the blinding disk of the Sun. But none of these reported observations were ever reliably confirmed, and all subsequent searches proved utterly fruitless. The profound mystery of Mercury's anomalous motion endured, unsolved. It was only in 1915 that Albert Einstein, with his revolutionary general theory of relativity, provided the ultimate elegant explanation. It turned out that no additional planet was needed. The anomalous precession of Mercury's perihelion is perfectly and precisely explained by the curvature of spacetime caused by the massive Sun, a subtle yet profound effect uniquely predicted by Einstein's theory, but entirely absent in Newtonian gravity. This became one of the first and most powerful confirmations of Einstein's groundbreaking correctness. The Vulcan hypothesis was definitively discarded. Today, the name Vulcan is reserved by the International Astronomical Union for this historical hypothetical planet, as well as for possible small asteroids within Mercury's orbit, the so-called Vulcanoids. But so far, no Vulcanoids have been discovered either. Vulcan remains to this day a ghost planet, a phantom born from the limits of an old theory. Vulcan turned out to be a phantom, a figment of a pre-Einsteinian universe. But another small world in the Saturn system proved to be a real astonishing surprise, Enceladus. This is the sixth largest moon of Saturn, and prior to the arrival of the Cassini mission, it was widely considered just another unremarkable, icy little ball. But in 2005, Cassini discovered something truly incredible. Intense cryovolcanism rages at the south pole of Enceladus. From long, prominent fractures in its icy crust, affectionately dubbed tiger stripes, powerful jets, or geysers, of water vapour, ice particles, and even complex organic compounds erupt violently into space. These colossal plumes reach staggering heights of hundreds of kilometres and are in fact the primary source of material for Saturn's diffuse E ring, the faint spread-out ring in which Enceladus itself orbits. This discovery was nothing short of stunning. It revealed that this tiny world, only 500 kilometers in diameter, is intensely geologically active, a small, vibrant ice world. Meticulous analysis of the data collected by Cassini during multiple daring flybys directly through these plumes showed unequivocally that beneath Enceladus's icy crust, which is several tens of kilometers thick, hides a global ocean of liquid salt water. As with Europa, the crucial source of heat maintaining this ocean in a liquid state is tidal forces generated by its powerful gravitational interaction with Saturn. But the most exciting aspect of all is the precise chemical composition of these emissions. Besides water, salts, carbon dioxide, ammonia, and methane, crucially, complex organic molecules and molecular hydrogen have been detected there. The presence of molecular hydrogen is a strong, compelling hint of active hydrothermal activity occurring on the ocean floor at the boundary between the liquid water and the moon's rocky core. Similar profound processes occur in hydrothermal vents on the floors of Earth's oceans. where chemical energy supports entire ecosystems in the absence of sunlight. The confirmed presence of liquid water, a robust energy source, chemical in nature, and all the necessary organic building blocks makes Enceladus, alongside Europa, one of the most promising and compelling places in the entire solar system to search for extraterrestrial life. Enceladus actively ejects water into space, while our own moon is slowly, inexorably drifting away from us. Yes, it's a verifiable scientific fact. The moon is gradually receding from the Earth. The speed of this escape is incredibly slow, approximately 3.8 centimeters per year, roughly the same rate at which our fingernails grow. But on the immense scale of billions of years, this seemingly minuscule change is profoundly significant. Why, then, is this phenomenon occurring? Tides are primarily to blame. The immense gravitational pull of the moon, and to a lesser extent the sun, causes the rhythmic rise and fall of high and low tides in Earth's oceans. But the Earth rotates on its axis much faster than the moon orbits the Earth. Because of this rotation and the immense friction of water against the ocean floor, the tidal bulges, these colossal bulges of water, slightly lead the moon's precise position in the sky. That is, they are not located directly beneath the moon, but are slightly ahead in the direction of Earth's rotation, and these leading tidal bulges possessing mass themselves exert a gravitational pull on the moon. Since they are slightly ahead, their gravitational pull acts on the moon, effectively pushing it forward in its orbit. This imparts additional energy to the moon and causes it to move into a higher orbit, meaning it recedes from the Earth. Simultaneously, according to the fundamental law of conservation of angular momentum, this transfer of energy from the Earth to the moon causes the Earth's own rotation to gradually slow down. That is, our days are becoming a tiny, almost imperceptible bit longer. This process has been ongoing for billions of years, a slow-motion cosmic dance. Paleontological and geological data meticulously gathered from ancient records overwhelmingly confirm this. For example, by studying layered sedimentary rocks, known as rhythmites, or the microscopic growth rings of fossil corals, scientists have determined that in the distant past, for instance, approximately 1.5 billion years ago, a day on Earth lasted only about 18 hours, and the moon was significantly closer to our planet, looming much larger in the sky. So the moon is slowly but surely drifting away from us, and our days are getting longer and longer. The moon is drifting away, but we left some things there forever. For example, American flags. During the 6 Apollo missions that successfully landed humans on the moon between 1969 and 1972, astronauts proudly planted 6 US flags on the lunar surface. These iconic moments became indelible symbols of human achievement and national pride. But what has happened to these flags over the past half-century, enduring the harsh lunar environment? The lunar environment is an extraordinarily inhospitable place. There is no atmosphere, which means absolutely no protection from the relentless, destructive onslaught of the sun's harsh ultraviolet radiation and cosmic radiation. The temperature swings between the lunar day, which can reach about 120 degrees Celsius, and the lunar night, when the temperature plummets to a staggering minus 170 degrees Celsius, are simply colossal. All of these extreme conditions are profoundly destructive to the materials the flags were made from, ordinary nylon fabric. Scientists believe that under the relentless bombardment of ultraviolet light and radiation, the vibrant colours on the flags have long since completely faded, bleached white. The nylon fabric has likely become brittle and disintegrated, turning into tatters or even fine dust. Analysis of high-resolution impressions meticulously taken by the Lunar Reconnaissance Orbiter, or LRO, shows distinct shadows from the flagpoles at the landing sites of 5 of the 6 missions, with the exception of Apollo 11, whose flag was likely knocked over by the powerful exhaust from the ascent stage as it departed. This means that the flagpoles themselves are still standing. However, the flags themselves, if they have survived at all, are likely completely white, bleached, and possibly severely damaged pieces of fabric. So the romantic impression of the Star-Spangled Banner proudly experienced on the moon is, alas, a thing of the past. The moon has, in its harsh indifference, bleached our symbols. The flags on the moon have faded, but the moon itself, as it turns out, is not quite the dead, inert world we previously thought. It trembles. Yes, there are moonquakes on the moon. Of course, they are considerably weaker and occur much less frequently than earthquakes on Earth, but some of them can reach magnitudes of up to 5.5 on the Richter scale. On Earth, such an earthquake could already cause damage to buildings. Seismic activity on the moon was first detected by the highly sensitive seismometers meticulously installed by astronauts during the Apollo missions in the 1970s. These instruments operated continuously on the moon until 1977, transmitting invaluable data back to Earth about the mysterious internal structure of our natural satellite. It was revealed that there are several distinct types of moonquakes. The most frequent are deep moonquakes, occurring at immense depths of 600 to 900 kilometers. They happen approximately twice a month and are unequivocally caused by Earth's powerful tidal forces, which subtly deform the lunar interior. Then there are shallow tectonic moonquakes, originating in the lunar crust due to the build-up and sudden release of stress as the moon slowly cools and shrinks. They are rarer but can be considerably stronger. The third type comprises meteorite impacts on the surface, which are also registered by the sensitive seismometers. And the fourth, weakest type, are thermal moonquakes, caused by the sharp extreme temperature changes on the surface between lunar day and night, which cause the crust to expand and contract, leading to cracking. What is particularly fascinating about moonquakes is that they can last much longer than earthquakes of similar strength, sometimes for tens of minutes or even hours. This is because lunar rocks are extremely dry and rigid, and they completely lack the water that on Earth quickly dampens seismic waves. Studying moonquakes helps us profoundly understand the moon's internal structure, its thermal state, and the ongoing geological processes occurring within it. Our moon is not dead, just quiet. Moonquakes tell us about the internal structure of the moon, but where fundamentally did the moon itself come from? The most popular and widely accepted theory today is the giant impact hypothesis. According to this theory, approximately 4.5 billion years ago, when the Earth was still incredibly young and largely molten, it suffered a catastrophic collision with another colossal protoplanet, roughly the size of Mars. Scientists have posthumously named this hypothetical protoplanet Theia, after the Titaness from Greek mythology, who was the mother of the moon goddess Selene. The impact was unimaginably powerful, a truly planet-shattering catastrophe. It resulted in the violent ejection of a vast amount of molten material into space, primarily from the mantles of both the proto-Earth and Theia. From this incandescent cloud of debris, which eventually coalesced into a ring orbiting the Earth, our moon formed in a relatively short period, perhaps just a few thousand years. This theory elegantly explains many fundamental features of the Earth-Moon system. Why the moon is so remarkably large compared to the Earth. Why the moon possesses an extraordinarily small iron core, because it is believed to have remained largely within Earth after the cores of Theia and Earth merged. Why the oxygen isotope composition in terrestrial and lunar rocks is nearly identical, unequivocally indicating a common origin of their material, and why the Earth-Moon system possesses such an immense amount of angular momentum, or rotational motion. Recently, another intriguing detail of this theory has emerged, adding a new layer to the narrative. Scientists meticulously studying seismic data about the Earth's interior have discovered two giant regions of anomalously dense material deep within the mantle, one beneath Africa and one beneath the Pacific Ocean. These are known as Large Low Shear Velocity Provinces, or LLSVPs. There is now tantalizing speculation that these colossal blobs might, in fact, be remnants of Theia's mantle, which sank deep into the Earth after the cataclysmic collision and have remained there, largely intact to this very day. If this proves to be true, then we are quite literally living on a planet that secretly hides fragments of another world within it, the very world that gave birth to our moon. The collision with Theia birthed our moon, but a collision with another object gave one of Saturn's moons a very recognizable and perhaps slightly sinister appearance. We're talking about Mimas. This small, icy moon, only about 400 kilometers in diameter, is famous primarily for its truly giant impact crater, named Herschel. The diameter of this colossal crater is approximately 135 to 139 kilometers, which is almost a full third of the diameter of Mimas itself. Imagine a crater of that relative size on Earth. It would be the size of Australia. The Herschel crater is extraordinarily deep, with towering walls reaching about 5 kilometers high and an impressive central peak that rises 6 kilometers above the crater floor. Scientists believe that the asteroid or comet impact that formed this crater was so monstrously powerful that Mimas itself nearly disintegrated completely. Indeed, intricate fractures and faults are observed on the opposite side of the Moon, likely caused by immense seismic waves that travelled through the entire body of Mimas after the cataclysmic impact. But the most amusing thing about the Herschel crater is its striking, almost uncanny resemblance to the infamous Death Star from the iconic Star Wars saga, particularly its super laser dish. This resemblance is, however, purely coincidental. The first Star Wars movie was released in 1977, while detailed impressions of Mimas with the Herschel crater were only obtained by the Voyager spacecraft in 1980. So George Lucas could not possibly have copied the Death Star from Mimas. It just so happened that nature, in its infinite creativity, created an object remarkably resembling one of the most famous fictional spaceships in cinematic history. We've seen that certainty is an illusion, but predictability is a rigorous calculation. May the fundamental laws remain beautifully constant as you rest, and may your dreams be framed by elegant equations.